So if you remember yesterday, we talked about building a probability or sample tree or tree diagram to help me determine probability of certain events, where now we are going to have compound events, which builds off of the tree diagram situation. For instance, the first one says, I roll a standard number cube, that's a dice, and then a coin is tossed. Notice then it says then. That means one event leads to the other. So what we do is we build a tree diagram. We do the standard number cube first. So how many sides of a cube? There are 6. 1, 2, 3, 4, 5, 6. Although now I'm going to shift gears. I'm actually going to do a vertical tree. I'm going to go sideways. 1, 2, 3, 4, 5, and 6. Now, from the 6 possibilities of a rolling a dice or a number cube, I'm now going to flip a coin. Well, think about how many sides to a coin. There are 2, heads and tails. So this is like saying if I roll a 1 first and then I flip a coin, I have a possibility of getting heads or tails. If I roll a 2 first and then I do a coin, it would be heads, tails. Then I roll a 3, heads, tails, then a 4, heads, tails, a 5, heads, tails, and then a 6, heads, tails. So I've built my tree diagram from that. Now, my total possibilities from both events, the 6 from a number cube and heads and tails from the coin, I look at my ends of my branches. How many branches at the end? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have total of 12 possible scenarios, okay? The first question says, what's the probability of getting heads? Well, I look at my tree diagram. How many heads do I have? 1, 2, 3, 4, 5, 6. So I have a 6 out of 12 chance of getting heads from those 2 events. When I simplify, 6 goes into 6 once and 6 goes into 12 twice. So I have a 50-50 chance of getting heads. That being said, if you remember our scale, 0 to 1, 50-50 means equally likely. Even number. So if I look at my tree diagram, my even numbers are 2, 4, and 6. But that doesn't mean it's just 3. I look at how many branches have that. So I have 1, 2, 3, 4, 5, 6. So I also have 6 out of 12 possibilities there. So then I simplify that. That's also 1/2, which is equally likely. Now then I look at the probability of odd number. So the first situation is an odd number and then rolling a tail. So if I read my tree diagram, I have my odd numbers are 1, 3, and 5. But from those, I need tails. So 1 tails, there's 1. 3 tails, that's 2, and 5 tails, that's 3. So there are 3 branches that have an odd number and then tails. So 3 out of 12. Rolling at least a 5. At least 5 means the least I can have is 5, so I can only have 5 or 6. And again, that doesn't mean 2. It means I look at how many branches those have. 5 heads, 5 tails. 6 heads, 6 tails. That's 4. 4 out of 12. When I simplify, 4 goes into both once and 3 times, so it's 1/3. I forgot to simplify this one. 3 twelves, 3 goes into both, 3 goes into 3 once, 3 goes into 12 4 times, so 1/4. Then we have 5 then tails. So if I roll a 5 and then tails, that's only 1 possibility. So it's 1 out of 12. And that's as far as I can simplify it. I know it sounds strange, but let's get more practice. These are called compound events because it's one event leading to another. If I look at number 2, it says the spinner is spun twice. Well, so I have my first branch, which are the possibilities on my first spin, A, B, 1, and 2. Then from that, I'm going to build another branch of how many possibilities there are for a second spin, which is 4. So each of my first spins is going to have 4 branches for my second spin. Okay, and so I have A, B, 1 and 2, A, B, 1 and 2, A, B, 1 and 2, A, B, 1 and 2. So I look at how many ends of branches I have. So I have 4, 8, 12, and 16. So 16 is my total for this case. The first question says, so all of these are going to be 16. Okay. The first question says letter both times. So if I look at my first branch, my tree branch, I have A, that's 1, B, that's 2. This one's A1, so that's not a letter both times. BA, that's 3. BB, that's 4. B1 is not a letter. 1A, 1B, none of those are letters, and these are not letters. So the only branches that have a letter, then another letter, are 4. So it's 4 out of 16. 4 goes into 4 one time, 4 goes into 16 4 times. So I have a 4th chance of getting a letter both times. B says at least one B. At least one B means at least one B or 2 Bs if possible. So if I look at this first branch, this is the only one where I have at least one B, so 1 from that tree. This one, at least one B here and at least one B there. Oh, at least one B on every single combination, so that's 4. This one has at least one B here, so that's 1. And this one has at least one B here, so that's 1. So how many total possibilities with at least one B? 4, 5, 6, 7. So 7 out of 16. Does not simplify, so that's it. What about A, then 2? Well, the only branch that starts with A and then 2, there's only one branch, so it's 1 out of 16. What about not spinning an A? So that means a branch cannot have A at all. That means that eliminates this tree. That eliminates this branch of this tree, but there are 3 here that do not have A. Okay, so this is 0. This one has A here, but the other 3 do not, so that's 3 there. And this one's 3 here as well. So how many do not have an A? 3, 6, 9. 9 out of 16, which you can't simplify, so there it is. What about 2 both times? That means my first branch has to have 2 and then 2 a second time. So there's only one branch that has 2 both times. So 1 out of 16. Let's do that again. The soccer team is selling spirit wear. Buyers must choose a t-shirt or a sweatshirt and then must choose between green, black, or white. So my first branch are the types of shirt. We have a t-shirt, and then we have a sweatshirt. I'm just going to put SW for sweatshirt. From there, they have 3 possibilities for a color. So I'm going to build 3 branches from the t-shirt and 3 branches from the sweatshirt. Those 3 possibilities are green, black, and white. Green, black, and white. Now I've built my tree. So how many total possibilities? Look at the ends of your branches. That's 3 and 6. So my denominator is going to be 6. Oh, that's all it's asking for this one is how many total possibilities. So what are my possibilities? A t-shirt that's green, a t-shirt that's blue, a t-shirt that's white, a sweatshirt that's green, a sweatshirt that's blue, or a sweatshirt that's, or black, sorry, and a sweatshirt that's white. How many of those sweatshirts or combinations can have a green sweatshirt? Well, the only tree that has a green sweatshirt is one branch. So that's 1 out of 6. Let's do another one. Darren is flipping a penny 3 times in a row. So we're going to have 3 total branches. We have heads, tails for the first combination. Then from there, he could flip a heads, tails the second time, or heads, tails the second time here. From there, on his third flip, he can have heads, tails, heads, tails, heads, tails, and heads, tails. Now, think about what this says. He, in 3 flips, he can have 3 heads. He can have a heads, heads, tails, a heads, tail, heads, a heads, tails, tails, a tails, head, head, a tails, head, tails, a tails, tails, head, or a tails, tails, tail. So that's how you can determine what kinds of flips he had in those 3 times. So how many total possibilities are there? You look at the ends of your branches. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 total possibilities. Of those possibilities, what is the probability of the penny landing on tails, tails, and then heads? Well, tails, then tails, and then heads, that's only one possibility. So it's 1 out of the 8. Okay. Rachel is ordering ice cream at a fast food restaurant. She can choose one size, small, medium, or large, and one flavor, chocolate or vanilla, and then one mix-in, chocolate candies or gummy bears. So her first choice is between the sizes. How many sizes are there? There are 3, small, medium, and large. After the size, she has to choose a flavor, chocolate or vanilla, chocolate or vanilla, chocolate or vanilla. From there, she chooses an add-in, chocolate candies or gummy bears. 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 So think about how we interpret this. She can have a small with chocolate and chocolate candies. She can have a small chocolate with gummy bears. She can have a small with vanilla chocolate candies, small vanilla gummy bears. She can have a medium chocolate candies, medium chocolate gummy bears, medium vanilla chocolate candies, medium vanilla gummy bears. You get the picture? So how many possible combinations can she have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. She has 12 total possibilities. What is the probability that Rachel will order a medium? Well, I look at just my medium branch. And how many branches are medium combinations? 1, 2, 3, 4. So 4 out of 12. You can simplify 4 out of 12. 4 goes into 4 once, and 4 goes into 12 3 times. What's the probability of small with vanilla and gummy bears? Well, there's only one branch that has that combination. So it's 1 out of 12 because it's very, very specific.